Good morning students, welcome back. We are in the day 6 session. In the last session we have studied about the working of ear, which helps us to hear the sound. In this session we will be studying about some characteristics of sound which helps us in understanding how we hear the sound. Some of the characteristics of the sound are loudness, frequency, amplitude. Okay, we will understand them with a few lab activities. Here we have done this activity earlier itself. Take a table, take a brick, keep the brick on the table like this. Now keep a thin blade or seesaw blade like this and keep the weight on the table so that it will not fall when you pluck it. Okay, the arrangement is take a table, take a thin seesaw blade or thin iron scale. Now keep the brick on it, weight so that it will not move. Now after keeping the weight like this, you need to pluck this seesaw blade gently and observe the number of vibrations made by it. Is it clear? When you pull this seesaw blade gently, you need to observe the number of vibrations made by it and also observe the intensity of sound. Intensity is with what loudness you hear the sound. Now repeat the activity by applying more force. Pluck it very fastly and observe the sound, and also observe the number of vibrations made by it. What is meant by a vibration? The to and fro motion of a body. For example, here originally it is in its mean position A. When you pluck it down, this blade will be coming down and then move up to A. Let us assume it to be B. C. It is already B. From here, it comes when you are plucking it. When you are plucking it, it is coming down and then going up and then coming back to its original position. This is called as one vibration. Now, this to and fro going up and coming back is called as one vibration. Now, what is the maximum displacement taken by the vibrating body? That means how long it is moving. In all the cases it is not same. When you pulled it gently and here you are doing it 2 times. Once you are pulling it slightly and the second time you are pulling it very high force. When you are pulling it high force and when you are pulling it gently, how much height it is going or the displacement taken by your seesaw blade is not same in both the cases. Your homework for today is try to do this activity and observe in which case the amplitude is more. Children, amplitude is nothing but the maximum displacement of vibrating body from its mean position. Mean position is nothing but, say originally your seesaw blade is here. When you pluck it from here, how much it is going and coming back. What is the height displacement made by the vibrating body is called as your amplitude. Finally, the conclusion of this activity is, what you infer from this activity is, more the amplitude, more louder the sound will be heard. Okay, next let us move with the intensity of sound. That is how, units. Your intensity of sound is measured with the unit decibel after the famous Alexander Graham Bell's names, in his honor. The intensity of sound units are given as decibels. Decibel is written like this with small letter D and capital letter B. Here are few intensities of sound. 0 decibels. The complete silence intensity of the sound when it is so silent is 0 decibels. And when I whisper, like talking very slowly, it's is 15 decibels. And the normal conversation between two people will be 60 decibels. And the car horns and all in traffic, it is 110 decibels. The intensities of different sounds are given like this. And coming to the other lab activity 2, here in this activity, we will be trying to learn about pitch of your sounds. What is meant by pitch? See children, when you are the same activity we are using, say bench, keep a seesaw blade, keep a brick in order to keep weight on the blade and try to pluck it like this. When you pluck it like this, say keep your hand like this. When you pluck it down, it is making some vibrations, right? It is making some vibrations. How many number of vibrations are done? See, keep the weight like this with the help of a brick and now try to pull it down. It is making some vibrations. How many number of vibrations are made in 1 second is nothing but frequency. Frequency is nothing but number of vibrations in 1 second. Now you tell me, here is an activity to understand different frequencies. Take a 30 centimeters, like this is 30 centimeters iron scale. Take a very thin iron scale of 2 iron scales or 2 seesaw blades of 30 meters length you take. Now, take the table. On this table, out of 30 centimeters, 20 centimeters should be placed see 20, this is 20 centimeters and the remaining is 10 you take it as 25 and only 5 you keep outside the table, 5 centimeters outside the table and 25 centimeters on the table. And you take another scale keeping 10 centimeters on the table and 20 centimeters outside the table. Did you understand, children? Here you need to take 2 thin seesaw blades or iron scales if you have very thin ones, and it will take 30 centimeters length seesaw blades. Now 25 out of 30 centimeters, 25 centimeters of the blade should be on the table and left over 5 centimeters should be outside the table. In the same way, another seesaw blade whose 10 centimeters is on the table and left remaining 20 centimeters is outside the table. Now keep the heavy bricks on them and repeat the activity, same pull it, plug it so that it vibrates. You observe the vibrations made by, now what the vibrations is done by 55 centimeters blade and 20 centimeters blade. Did you understand now? When you pluck it, the vibrations made by 5 centimeters and 20 centimeters you observe At same time, you will be observing in this activity that which scale or which seesaw blade is making more vibrations. You will observe observations of this activity. You will observe that 5 centimeters will make more vibrations than 20 centimeters. 20 centimeters will vibrate for less number of times. Vibrating for less number of times or more number of times, what you are comparing here? You will be getting that more the number of vibrations. Frequency is nothing but number of vibrations per second. As more number of vibrations are there, your frequency is also more. It means your 5 centimeters blade will have high frequency than when it is compared with 20 centimeters. So 5 centimeters will have high frequency and 20 centimeters blade will have low frequency. Will have lower frequency when it is compared. So what you will get, what you can infer from this? See, when you plug them, they are vibrating and they make some sound. Whose pitch is more? Pitch always depends upon frequency. Higher the frequency, higher will be the pitch. Lower the frequency, lower will be the pitch. Now you tell me, where in which case the pitch is more? Pitch is more for the scale whose frequency is more. That is for 5 centimeter scale, it will have high frequency and high pitch than your 20 centimeters scale. To understand more about this pitch, let me take men's voice and women's voice. Women's pitch will be more shrill when you compare with the men. And if you take birds and lion roars, the sound of lion roaring and the birds chirping, if you compare these sounds, pitch of the birds will be higher because it makes, it will be very thin and it makes more number of vibration. It means that frequency is more for it. That means in everyday voices, or if I say A, E, B, O, C, D, letters of, alphabets, each alphabet will be having different frequencies. So when I am talking, what is my frequency? It's mixed frequencies will be there. And also, when I communicate, I use different frequencies or mixed frequencies I can say. Now, for example, let me take the word no. No is used in different cases, in different situations. For example, in the class, you ask the teacher, "Ma'am, can I go for the break? And can I have some water?" If the teacher resists you, she says no. And no can be used in anger also. No, you can't do it. This no is different. The anger, when I say no in anger, is different from resisting. When I say I stopped you from going, no, don't go. No. No in anger and no in resisting is different, and you are using in different pitches. With different pitch, and its frequency is also different. Its pitch is different because of its frequency, because pitch depends upon frequencies. So, coming to the different sounds, different sounds we hear every day is sounds are very peaceful to hear. Some are louder, some are irritates you, which I call it as noise. In everyday assembly, you can hear drums and we sing song Vande Mataram and we take oath pledge in the assembly, right? The sounds of drums are very louder. I can say intensity of the drum sound is more when it is compared with when you are singing the song or taking the oath, or when you are reading that pledge. I say when you are reading the pledge, I can say that it is feeble. It's not louder. It's feeble, I say. So in everyday life, we hear different sounds. Some are good to hear, we love to hear like music, and some we get irritation or we don't like to love to hear, and such sound is called as noise. And noise is usually made, teachers say in the classroom usually don't make noise. Don't make noise. What does the noise mean? She doesn't say don't make sound. She says don't make noise. What do you think noise is? See children, when the class is of 20 or 30 students in the classroom, different child will have different frequency, different loudness, different amplitudes. When you are talking, mixed, you have no regular frequencies, right? The frequencies of you are not regular. If I sing sa, re, ga, ma, pa, da, ni, sa. When I say sa, re, it's high, low, it has an order. When I sing sa, re, ga, ma, pa, it has an order. I do follow the order, but when you make noise, you don't, or when you are talking all different 20 to 30 children talking in the class, the pitch or the frequency of yours are not in order, which creates noisy atmosphere. That's the reason teacher says don't make noise. She doesn't say don't make music or don't make sound. Did you understand? So that's the reason it is so it irritates us. Like try to go on the busy road, stand somewhere and try to hear the sound. Different sounds make different frequencies. When you stand on the road, people on the roads, we hear vendors' noise, we hear different sounds, traffic sounds, different vehicles make different sounds. These all creates mixed or they don't follow an order of frequencies, which creates noise. Like air pollution and water pollution, noise pollution is also very dangerous to health. It causes hypertension, sleeplessness. Many health issues are caused by noise pollution. So, not only the busy roads, but also the grinders, mixer grinders at our home, washing machines also create sound pollution. And we need to, in order to overcome, as it is very harmful for human health, we need to overcome them by developing or by manufacturing the motors or instruments with devices, electronic devices with less noise. We have to design them, and also we have to plant so many trees, and we have to use silencers in the automobiles to reduce sound pollution. And we need to avoid these loudspeakers in the marriages and functions. So we need to avoid sound pollution. And this helps us to avoid or overcome sound pollution to live a healthy life. That's all for today's session. Thank you.